Gravel is very common in our daily lives. But do you understand what kind of gravel? Can it be used for bridge construction? In this lesson, we will learn together. Test detection of stone material for bridges. Related content. Key learning points of this section. 1. Stone material technical standards. 2. Stone material mechanical performance test. 3. Stone material freeze-thaw resistance test. There are two methods for obtaining stone materials. The first type is made from natural rock. Large block stones obtained through blasting. Then, according to required specifications, obtained through rough or fine processing. Regular or irregular rubble stones, dress stones, etc. The second type is made from natural pebbles, cobbles, boulders, processed into stone products for bridge and tunnel engineering have flagstone, rock block, roughly dressed stones, etc. These stone materials are mainly used for daily masonry engineering, such as the arch ring, abutment, basic, conical slope, etc. According to the Highway Bridge and Culvert Construction Technical Specifications and the Highway Masonry Bridge and Culvert Design Standard. Relevant requirements. Stone materials used in structures generally includes two aspects of performance requirements. One aspect is stone products, physical and geometric size requirements. On the other hand, there are mechanical performance requirements. First, let's learn about for the physical requirements of stone materials. 1. Stone materials used in bridge construction should comply with the category and strength specified in the design. The stone should be uniform. Ensure it is not prone to weathering. No presence of cracking. 2. Average January temperature. Regions below freezing temperatures, except for arid regions. Non-freezing locations. The stone and concrete materials used must pass the freeze-thaw test. Only those meeting freeze-thaw resistance standards can be used. Freeze-thaw resistance indicators should comply with the regulations in the table below. 3. Due to the unique environment of bridges, the stone used must also have weathering resistance and erosion resistance for submerged locations or in regions with prolonged humid climates. Softening coefficient of load-bearing structural stone should not be less than 0.8. Dimensional requirements are as shown in the table. For stone materials used in bridge engineering, besides, there are relevant technical requirements for physical properties. During stone material processing, we also ensure the shape and specifications of stone materials meet requirements to ensure the safety of the bridge structure. Specific size and specification requirements for various materials are shown in the table below. 1. Factors affecting uniaxial compressive strength of stone materials. Compressive strength reflects the stone materials, one of the main indicators of mechanical properties. In engineering, we adopt uniaxial compressive strength tests. For the strength of regularly shaped stone materials, conduct measurements. The main factors affecting the strength of stone are mineral composition and structure, moisture, specimen size, etc., among which softening refers to the influence of moisture state on stone material strength, expressed by the softening coefficient. The strength of stone materials, the specimen specification, and conversion should comply with design requirements. The determination of stone material strength shall comply with current Highway engineering rock test procedures. Strictly implement. 2. Testing standards for uniaxial compressive strength of stone materials. 1. Instruments and equipment. Pressure testing machine. It is the most essential detection instrument. Its measurement accuracy should be plus or minus 1%. Loading range of 20 to 80%. While having loading control. Bearing plate size, stiffness, flatness, spherical seat, etc. Must meet specification requirements. Stone specimen processing equipment includes stone cutting machine or diamond drilling machine, grinding machine. The stone specimens prepared. Other instruments and equipment also include oven, desiccator, sliding gauge, square, as well as water pools, etc. 2. Sample preparation. Cubic specimens required for detection. Side length should be 70 mm plus or minus 2 mm. The number of specimens is 6. Generally in rocks with significant bedding. Prepare specimens along parallel and perpendicular bedding directions. During preparation, ensure flatness tolerance is less than 0.05 mm. Vertical deviation less than 0.25 degrees. 3. Test steps. When everything is ready, we can then commence formal testing. First, Step 1. We need to prepare for each specimen. Label the numbering and measure the side length, including the top and bottom surfaces. Calculate the compression area based on measurement data. Step 2. Determine the moisture state of specimens as needed. Oven dried state, natural state, saturated state. The drying condition requirements are temperature at 105 to 110 degrees Celsius. Time is 12-24 hours. Cooled to room temperature 20 plus or minus 2 degrees Celsius. 4. Saturate the specimens. The boiling method can be used to saturate specimens, and vacuum extraction method to saturate specimens. Step 3. Based on the strength properties of stone materials, select an appropriate press machine. Place the specimen at the center of the press machine's bearing plate. Align the upper and lower bearing plates. Must not be eccentric. Step 4. Load at a rate of 0.5 to 1 megapascals/s. Until failure. Record the failure load and during the loading process. Observe phenomena. Maximum load recording from compressive specimen tests. In units of N. Accuracy 1%. In the end, according to the stone material compressive strength calculation formula and the softening coefficient calculation formula, calculate the experimental data. The calculated value of the softening coefficient is accurate to 0.01. First, take 3 specimens for parallel testing. Take the arithmetic mean. Maximum and minimum values do not exceed 20% of the average value. Otherwise, take another 4 specimens. Take the average of the 3 closest values as the calculation result. However, the report should simultaneously list for values. Let's understand stone material freeze-thaw resistance testing. Freezing resistance refers to rock in a water-saturated state, subject to specified freeze-thaw cycles. After freezing or thawing cycles, resistance to failure. Freeze-thaw resistance is usually measured and expressed by rate of quality loss and the freeze-thaw coefficient. We can repeatedly freeze and thaw the material, then observe the material after freeze-thaw. Strength variation, quality loss, appearance changes. These 3 indicators are used for evaluation. During testing, freeze-thaw cycles in severe cold areas should be 25 times. In cold areas, it should be 15 times. If the material shows no obvious damage after the test, mass loss rate not more than 2%, strength not less than 75%, then it can be judged as a qualified product. Instruments and equipment include a specimen processing equipment, outside the pressure testing machine. Also includes a refrigerator, balances, etc. Relevant test equipment must meet standard requirements. The specimen is a cubic sample. Side length 70 mm plus or minus 2 mm. 6. Specimens. Test steps. I. Number the samples. Appearance description. Measure the compression area. Weigh the dried sample. 2. Perform water absorption saturation. Freezing and thawing. Repeated freeze-thaw testing. After a certain number of freeze-thaw cycles, inspect specimens for spalling, cracks, stratification, and corner spalling. Weigh after freeze-thaw cycles. Oven dry and weigh. Measure water saturated compressive strength. Finally calculate the mass loss rate. Water absorption rate after freeze-thaw. Freeze-thaw coefficient. And evaluate based on relevant indicators. In this lesson, we learned technical standards for stone materials used in bridges, mechanical properties test of stone material, freeze-thaw resistance tests and other content. Hope you in future work take test detection seriously. Strictly control material quality.